Hello all, welcome to ENH iSecure blogs. I'm Kishore Gaddam, working as an architect in ENH iSecure. Today I'm going to explain the recommendations for SailPoint IAQ architecture. The primary focus on this blog is how to handle the failover. Agenda is IdentityIQ reference architectures, business continuity in general, business continuity in IdentityIQ, how to set up the ER environment in IdentityIQ, and a demo environment. First one is SailPoint IdentityIQ reference architecture. Introduction. So SailPoint is a leading identity access management solution designed to help organizations to manage and govern user access to various systems and applications. The top identity security solution provider on-premises or self-hosted solution and IdentityIQ reference architectures. So basic architecture is simplified is like this. So either request from desktop or laptop or from my mobile. So when you send any request, so from the via internet, the request goes to the web application server, and the web application server will be deployed with any of the web applications, and from there the request goes back to the database, and whatever the request information is needed from the database, it will respond accordingly and then sends back to the server, and the request goes via internet to the customer, either from the user 3, user 1 or user 2. SailPoint is classified the servers as two types. One is UI server and task server. So we would like to understand like what is UI server and task server, what is the main differences between them. So the server UI servers, the servers handle the user interface related tasks, and task servers, the servers are dedicated to processing the background tasks and requests, and they are responsible for managing the user interactions such as logging, navigation and data display, and task servers operations like data aggregation, report generation and other scheduled tasks. So the other US servers dedicated to specific US server, the system can provide smoother and more expensive response experiences for end users. And for task servers, segregating the task processing from UI operations helps ensure that the intensive background process do not impact the responsiveness of the user interface. And US servers have low latency response, whereas for the task servers, high throughput, long running process, and also task servers can be scaled horizontally to handle increased workloads efficiently. A single facility tutor architecture, which means like when a user requests and the web application will respond back. Here in this tutor architecture, I have facilitated one load balancer and the backend one data center is available, and the load balancer will take the load how to split from the US server 1 to US server 2, and the task on server 1 server 2 to do processing of the job backend jobs and all. So this is simple IAQ two-tier architecture. It has several advantages, especially for simplicity, cost effective and faster execution and direct communication. Because why? Because the data center having all the UI servers and data servers are reside on the same server, and as well as the database server in the same data center. Because of this, so the communication is easier to communicate. This is suitable only for the smaller web applications. Whereas if it is a crucial systems, it might be fall down and may face some issues. Few benchmark we should consider while designing the architecture. One is data block size and the response time. So while designing SailPoint IAQ, the average round trip time, response times for data transactions are important for ensuring the optimal performance. So average round trip ping time for 1K data block for all applications servers to the database is 300 microseconds or less. And average round trip commit time for 1K data block is the response time is 9 milliseconds or less. Average round trip commit time for 4K data block and the response time is 17 milliseconds or less. An average round trip commit for an 8K data block and the response time is 20 milliseconds or less. And the second one is business continuity in general. So we'll understand now what is business continuity. It means like to ensure the uninterrupted functioning of the business during after any disruptive event. It means like any critical business operations can continue during any after a disaster, uh, so that like we can minimize the downtime and all. This is called business continuity. So we call it as a BCP as well, business continuity plan, and which has several things: risk assessment, impact analysis, mitigation strategies, recovery plans, testing and review. Risk assessment means identifying the potential threats such as natural disaster and cyber attacks or pandemics. Impact analysis, understanding how these threats could be affect business operations and all. Mitigation strategies, implementing the safeguards and procedure to reduce risks. Recovery plan, establishing steps to restore normal operation as quickly as possible. Testing and review, regularly testing the plan and to identify and correct any weakness. So another one is disaster recovery. So what is disaster recovery? And it is a process which an organization attempts to prevent or minimize the loss of business and data in the event of disaster. It is about how an organization bounces back and regains normally after the catastrophic impact of such events. So disasters can have a significant impacts on the software systems, affecting both functionality and security applications. Some of the key impacts is kind of data loss, downtime, security breaches, corrupted data, and disruptive events. So how do we handle the failovers? So such as like any cyber attack is happening and any other primary instances happen. So how do we handle that? And what is the mechanism that we use? So the failover is simply in terms of process of automatically switching to standby system or a component when a primary system fails. This ensures continuous operation and minimizes the downtime. And what are all the failure mechanisms? So a server failure, a network failure, a database failure, or application failure. How do we implementing failure mechanisms? So identify critical components, set up redundant systems, automatic monitoring, and the failover procedures. So if we make ensure that like BCP business continuity plan and the failover handling, so what are the benefits are there? So ensure that the critical business operation can continue during and after a disaster or minimizing the downtime. One of the benefit and the data protection. So provides robust data backup and recovery solutions, safeguarding against data loss and the compliance. Helps to meet regulatory requirements for data protection and disaster recovery and scalability can be scaled to accommodate growing business needs and data volumes. These are all the few benefits that I written here. So far we see what is business continuity planning in general. Now we'll apply this in IdentityIQ. Here it is simple DC-DR reference architecture. So I have one load balancer and we have two data centers. One is a DC and one is a DR center. And there is a primary database and DR database. When you switch over from the DC to DR, so the respective databases will be up and running. This is active and passive DC-DR architecture. And you see like in database always one phase commit from the primary database to DR database. So DR failovers can be handled using load balancers and database replication. So I'll talk about load balancers, how we can able to handle it. So what is load balancing? It is the process of distributing incoming network traffic across multiple servers. This ensures no single server bears too much demand, leading to improved performance and availability. So one of the there are a few marketing available. One of these NGINX is an open source software known for its high performance, stability, and low resource consumption. And it handles the multiple load balancing methods on larger number of connections and simultaneously, and it is easy to configure. There are few algorithms that are supported by NGINX. One is round robin and list connections, IP hash, and generic hash. So most importantly, we need to understand some note is like SailPoint supports the IP hash and generic hash load balancer mechanisms. Why? It maintains all session management and push it up to the load balancer, which must be configured for server affinity and sticky sessions for end user sessions. The load balancer must route to a server to the same UA server if that UA server is online and available. So another dear failure is replication. Replication is a process where data from a main source is duplicated to one or more replica nodes. So consider like a MySQL logs events in bin log file for replication. This replica nodes uses this bin log file to persist the data in their end. And there are two types of replications. One is position based replication and the other one is GTID replication. So in our demo environment, we'll be using our position based replication. Now we have our environment, ENH environment. So it is called two data center architecture. It's composed with primary and or active data center and a secondary or standby data center. So if you see like we have defined active and standby data centers. The database layer replication data over the WAN in the background so that the data from the primary data center is backed up into the secondary data center. This type of architecture is recommended by IdentityIQ with the following conditions meet. Okay, so the database replication must be in one phase commit, not two phase commit, where the primary data blocks until the secondary has committed the transaction. So we need to make sure like our DBA to configure the database replication with the one phase commit. Since SailPoint is supposed to active passive architecture, so the task servers and the secondary data center do not have their application servers running when the primary data center are in use. It means like when it is in active and these servers, application servers must be in a stop mode. The UA servers in the secondary data center do not have their application servers running when the primary data center is in use. The same way like UA servers also will be in a stop mode. So the load balancer has to be configured to route traffic only to the UA servers in the currently active data center for user sessions. So the connections from the load balancer to the secondary data center. So we need to show it as in we are showing currently the dash diagram to illustrate that what is the primary center and what is the standby data center where it is routing using the load balancer. So ENH also recommends this kind of environment, and also we have proposed a load balancer replication as well. So in this load balancers as well, we have utilized the two load balancers. One is active and standby process. So using that active standby it includes the traffics under normal control conditions, while the secondary load balancer remains standby. So primary load balancer, which is an active, it means like actively manages and distribute the incoming request traffic to the servers to the primary data centers, continuously monitors the health and performance of the servers in the network. So whereas secondary load balancer standby remains in standby, not handling any traffic under normal conditions. regularly synchronizes with the primary load balancer to stay up to date with the current state of configurations and the failover process. So if the primary load balancer detects failure or significant issues, it triggers to the failure process. The secondary load balancer becomes active and starts the handling traffic to ensuring the minimal disruption. So the failure process, once the primary load balancer is restored and verified and fully operational, traffic can be redirected back to the primary data center, primary load balancer. Uh, we are recommending this setup is highly for any of the environment. Why? Because if there is any intrusion happens, we can make sure like we have secondary load balancer is always available. In this architecture, if you see like we are primary load balancer always routed to the active data centers where when it is primary is down, our ENH load balancer DR center will actually monitor to the routed to the secondary data center. So this kind of recommendations we have set up in our environment and which is working successfully. So I hope this DCDR we can achieve using this architecture, DCDR architecture, and this recommendation is highly uh, encourageable by ENH. Demo environment components: two UI servers, one DC, one DR, two task servers, one DC, one DR, two MySQL servers, one DC, one DR, and two load balancers, one DC and one DM. So DC is always act as a primary and DR is a backup servers. So how failover can be demonstrated? So if you see like in our demo environment having NGINX database application, other things are there. So based on that, we are providing and going to provide some recommendations here. For NGINX, configure only UI servers in load balancer. And there is another important thing is sticky session. Configure the load balancer for sticky session to ensure that user sessions are consistently routed to the same application server. And for the database replication, configure your database for replication to ensure high availability and disaster recovery. Use native database replication features like MySQL replication or Oracle Data Guard. Data must be one phase commit. While replicating, make sure your IdentityIQ, ENH, IdentityIQ plugin are only replicating. So in general, this kind of setup ensures that SailPoint IAQ can handle high traffic loads efficiently while maintaining data integrity and availability through database replication. So please follow our ENH iSecure. We have a couple of branches, headquarters in Hyderabad, Bangalore, and US offices. Also follows our social media. Thank you. Signing off, Kishore.